Hey guys, before we get started on today's solution, just a quick reminder in case you missed my special announcement video. Now you can download free copies of the problem before you watch my video so that you can try the problems ahead of time. I hope that will help you guys out and get you excited more for watching the solutions. So hope you guys like it. Please smash that subscribe button. I am an infant YouTuber drinking smoothies. So just kidding, but I hope you guys like this one today. Now, before we get started on the problem, let's talk about prime factorization. Prime factorization is all about breaking up a bigger number as a product of smaller prime numbers like 1, 2, and 3 that are only divisible by that number or 1. So an example of prime factorization is breaking apart 4 into 2 times 2. So now let's do that with all of our numbers. So 1, 2, and 3 are already prime. 4 can be written as 2 times 2. 5 is prime. 6 can be written as 2 times 3. 7 is prime. 8 can be written as 2 times 2 times 2. And 9 can be written as 3 times 3. Now, do you guys notice anything special about the numbers after we group them? It looks like all the numbers can be written as a 2 or a 3 with the exception of 1, 5, and 7. Because 1 is probably going to help us out later, anything multiplied by 1 is the number itself. Let's keep 1 and eliminate 5 and 7 because they are the odd ones out. Now let's count how many of each number there are. So if I start with 1, there is 1 1, so I'm going to write 1 1s. For 2s, there are 1, 2, 3, 4, 5, 6, 7. So there are 7 2s. And then for the 3s, there are 1, 2, 3, and 4. So 4 3s. Now with the numbers we counted in the last slide, I rearranged them into a horizontal row. So there was 1 1, 7 2s, and 4 3s. Now let's go ahead and take a look at the hyperhelix. With the hyperhelix, this vertical column here, I'm going to call this group 1. This vertical column, group 2. And then the horizontal row right here, group 3. Now, after taking a look at the horizontal numbers here, we can also say that we could group them in order from 1, 2, and 3. So if we do that, we can make a group here. That's the first group. This could be the second group right here. And then the third group, I understand it's not going to be equal to 1 and 2, but let's hold off on that for 1 sec. Now, because the numbers are the same for 1 and 2, we know that the products are going to be the same. So the vertical rows 1 and 2 are going to have the same products. Now let's see if we can sort of reverse prime factorize and bring it back to the original numbers. So I'm going to go ahead and cancel the 5 and the 7 because those are the numbers we already eliminated in step 1. Now, if we circle the 3 2s here, that can go back to an 8. And the 2 3s here can make a 9. So I have 8 and 9. So I can make 8 times 9, which is equal to 72. Now let's take a look here. We can group the 2 2s together to make a 4. 3 and the 2 together to make a 6. And then we have a 3 left over. So 4 times 6 times 3, that would also equal 72. So I'm going to go ahead and cancel the 3, 4, and the 6. Now, if you notice on the third group, there's only 2 numbers left, and which is totally not equal to group 1 or 2. But if you notice something special about the third group right here, you can notice that it's being 2 numbers are being shared with 1 in group 1 and 1 in group 2. That means the same number here is gonna go inside there, which we used in 1 and 2. Now, also, if you notice, group 1 only had the 8 and the 9. So what if we took this one over all the way to group 1, because 1 doesn't do anything with the actual outcome. So group 1 became 8, 9, and I'm just going to add the 1 right there. So I'm going to cancel the 1. Now we have the 2 left. Now we have the 2 left. So we know that the product has to be 72. So if we take 72 and divide it by 2, that's going to equal 36. 36. Now, because we have to pick one number from 1 and 2, the only 2 numbers that multiply to 36 are 9 and 4. So we know that the last 2 numbers for group 3 is going to be 2 times 4 times 9, which gives us our 72. So if we fill out the hyperhelix, we know that it will have 8, 9, and 1 for the first group, 6, 4, and 3 for group 2, and then 2 in the middle for group 3. So all 3 columns will have a product of 72. Comment below, let me know how you guys did. As always, I'd appreciate it if you hit the like, smash that subscribe button, and turn your notification bell on so you know exactly when I upload new videos. Thanks for watching, guys, and see you next time on Math Challenge. Bye-bye.